Well, another part of the hobby of collecting has been these meters, which we've come across, and I'm glad I bought them now because I've got quite a good collection here. I have borrowed one or two from a friend just to supplement the display, mainly of multimeters which he collects, but mainly all the little pocket meters which I've collected have been found in the local antique shops and boot fairs and places. They range from about 1911 is about the earliest one I've got, up to about 1942, I think, the multimeter over the back there. And most people had a meter in the early days, because you must remember that they had, with the battery sets, an accumulator and the high tension battery. And without the aid of a meter, they couldn't tell whether it was the accumulator gone down or the HT battery. So a lot of people purchased these little tiny meters. Pifco was the main brand in those days. But then they added extra facilities, not only for testing the HT and LT batteries, they also made them where you could test the filament of the valve as well. And so, as I say, most people who had a set in the early days had one of these little test meters. So we'll have a close look at some of them now and see some of the most interesting ones. We can't show them all because we'd be here for another 2 hours, I should think. This is one of the most common type of meter. It's all Bakelite and has two ranges. The common lead is this one here, and of course, being a moving iron meter, doesn't matter if it's AC or DC, hence the AC and DC signs here. This range on this one, on this probe and the common, it's up to 8 volts full scale deflection, and on the top range, on the other probe there, is 160 volts. Made of Bakelite, quite a common sight I should think in the very early days. Nothing too pretty about this one, a very, very basic meter. This one's a little bit more of the upper class. It's actually a moving coil meter, made in France, and has two ranges. This time it only has a single probe here, but it has two wires, the red and the black. So you have the red for the low scale, which is 0 to 8 volts, and the black lead from 0 over to about 100 volts. And this, of course, is in a nice little nickel case. So a little bit more expensive, I would have thought, than the last one we saw, the Bakelite one. Another one, this one's got a range from 12 volts on one leg and 120 volts on the other. Common lead here. Moving iron meter, radio voltmeter it calls itself, and a resistance of 8,000 ohms on one scale and 800 ohms on the other scale. I'm sure this is a moving iron meter. And interesting thing, it's made in Bavaria. Nickel plated, of course. Here's one with just a single range, 0 to 15 volts, was only suitable for testing the low voltage part of the radio up to the accumulator and that sort of thing. Moving iron meter again, positive terminal down here and the negative on the top. This one again, moving iron meter, 0 to 6 volts, 0 to 120, standard range again, the two probes at the bottom. No indication of where this one's made, but looking more like a pocket watch than the other types of meters which we've seen. This one's rather an unusual one. It says here lamp amp meter with the wooden plug for the bulb and the bulb holder on the bottom here. So obviously this one was designed for testing the amperage of each lamp. I take it it's before they were made and marked with what current they were drawing, so that you could tell how bright the bulb was going to be by measuring the current it consumed. It's just virtually like a pocket watch with a nice holder, standard bayonet holder on the bottom there. But quite a nice meter, that one, rather an unusual one. This is rather a nice one, complete in its original box, and just like a pocket watch again. They're all, I think they must have been built in pocket watches. The inside of pocket watch is removed because they all seem to be the same style. This one's direct current, it says, a voltmeter, 0 to 120, 0 to 12 volts, foreign manufacture. This one's a rather nice meter. It's all brass, Galvo, number 24A, Mark 1, 1941. It's very, very nicely made, and we'll have a close-up look. It's made by Cambridge Instruments, so as you can imagine it's going to be quite a nice meter. This claims it has a resistance of 47.8 ohms, with a huge magnet there, and a very interesting way the coil is mounted. We'll have a close-up look on that. Where the coil is actually mounted on the gimbal there, it's like a very large ball bearing in the centre there, about 5/8 of an inch diameter, and the coil is round there. I'll try and shake the meter a little bit so you can see it actually moving. I don't think it'll be too successful though. But a very nice meter, this one, by Cambridge Instruments. The connections are on these two large brass terminals here. The whole thing came in a leather case. The top, the glass here, is about a 1/4 inch ground glass, plate glass. It also has at the back there that when you lay the instrument flat on a hard surface, it releases the coil inside there, so that when it's in transit and you're carrying it about, that the coil doesn't wobble about all over the place. So there we are, that's the Cambridge Instruments galvanometer. This one is a hot wire meter reading amps from 0 to 1 amp, used in aerial circuits. It says HF2, and it was made in 1927 by H.W. Sullivan Limited, who made a lot of early radio equipment. It has two ranges. There's normal, where you can go straight through without going via the meter. Double, it has normal for there, or you can double the range to make it up to 2 amps, or you can go straight through without going through the meter at all. So once you finish tuning up your aerial circuit, you could switch the meter out. The way the hot wire meter worked, that the connection was here and here. There's the hot wire, which is suspended from there over to there, fixed at this point here. When it got hot, of course, this would sag. Now this little piece of cord went round the actual meter itself and was fastened to this spring here. So it was always under tension, pulling it this way. So when it sagged, it would pull down that way, and round would go the meter and give you the reading across here. So that's the way the hot wire meter worked. This one's a rather nice meter. It's all brass and obviously meant for a front panel mounting, where it would mount straight onto the surface of a panel. The connections are in the front here, near the side, and it is a moving coil meter, this one. This is the Pifco all-in-one meter. It's virtually like a little multimeter. The negative connection is here, put the plug in there, and another negative over there, positive 240 volts there, 8 volt there. It's a very clever little meter, this one, which tests valves, high tension, low tension, circuit test, milliamps, and it has a resistance of 6,000 ohms. Also in the back is the position where you can plug the valve in and test the filament. And the only test it done is with the internal battery which is in there, and you just put your valve in and tested it like that. It will give you a reading whether the filament was okay or not. There we are, we can see the ranges which this little meter has now. There's the rear of the meter with the full instructions of how to use it. And we'll remove the back and show you where the battery went inside. There we are, that's the back removed, and you can see the little HP7 battery there for doing the tests on the continuity of the filament for the valves. So there we are, that's a little Pifco all-in-one multi-test meter. This is the Pifco electrometer, AC and DC, obviously moving arm meter, up to 250 volts and 5.5 volts. The connections are with these little plug-in connections at the bottom here. So there we are, that's the little Pifco, all in a Bakelite case with a little brass handle at the top here. This is another Pifco all-in-one meter. It's actually the same ranges as the one we saw a few moments ago, but this one's in a nickel case. Another meter by Pifco, getting more like the multimeters which we know now, the same sort of shape. Has the facility for testing a valve in the top here. This is called the all-in-one radio meter, AC and DC. Terminals along the top here for your connections, all in a little Bakelite case. This is the little plate which is on the back of the meter, telling you how to make all the connections and what to use them for. Valve test, HT test, LT test, milliamps, and it has an internal battery, this little meter. There we are, that's the little Pifco radio meter, AC and DC. First of the little multimeters as we know them, the same sort of shape anyway. Well, here's a selection of the meters which we have. Far too many to talk about individually, and we'll just show you a few of them, and then we'll get on to some of the multimeters and the other galvos which we've collected. But as you can see, there are a lot of these types of meters made. A lot of them were foreign, made in either Germany or France, and I should imagine every household in the country who had a radio had one of these meters of some sort or the other. This is a nice little meter which I found, all mounted on a little wooden plinth here with a wooden surround. It's a moving arm meter, 0 to 5 volts, and I had to put a new background. It was in pretty sorry condition when I found it, but it's a type of meter that they used in a school for demonstrating, and was made by a company called Philip Harris, who are still manufacturers of equipment for schools. and this dates back to the early 1900s. There's a nice meter made by H.W. Cox and Company Limited, 0 to 30 volts. A very heavy brass meter, this one, with a plate glass. This is a galvanometer, very early one, 1916, made by W.G. Pye and Company. Has the 3 terminals on the top here, marked I and Q. There we are, we can see the terminals marked I and Q there. Very nicely made, this one. I should imagine it's made for the post office. So there's the little Pye galvanometer. Another one here, very similar, except that the dial, of course, on this one is down the bottom. Dial at the top on the Pye one. 3 terminals again, and similar type of box, mahogany box. We'll have a closer look at this one, especially at the inside of it. Well, there we are, that's the little Edison one. We'll have a look in the inside just to see how it's made. And as you can see here, very heavy brass, the 2 coils, all brass work in here, very, very nicely made. There we are, there's a close-up of the inside. So well, there we are, that's the little Edison galvanometer. The other galv I have is this sort of Gothic style one. It needs a new glass, and it's a piece out of the cabinet here. It's a very nice one, and it's a GPO written on the front dial there. The mechanics are all there, and this one, as I say, I've got to restore, but I should have quite a lot of pleasure in doing this. I rather like the shape of this one. There we are, that's a close-up of the dial, and as you can see, GPO written on there. We'll have a look at the inside of this. Let's have a look at the inside. I'll try and give you a bit of a close-up on this to see the workmanship that went into this. All solid brass, including the dial, about 1/8 of an inch brass. The connections in here from the 2 coils go onto these large brass strips here, which go down to 2 little coils in the base here. Obviously these must be resistances, but all the connections are on this heavy brass work. There's a side view of the galvan. Connections for this one are on the back here, 4 terminals, very heavy brass terminals. So there we are, that's the old GPO galvanometer. We'll have a look now at 1 or 2 of the multimeters. This one's a very, very early Avo minor, around about the 1930s. It's type HR. As you can see, it's complete in its original little case. The connections on this one, of course, are negative here, which is a common. You've got a 250 volt, 1000 volt, 25 volt, and 100 volt range, and also 10 and 2.5 volt and 250 microamps. It looks like the scale has been sort of handwritten. There's the instructions of this little Avo on the back, all clearly written how to use it. and you notice that it's 20,000 ohms per volt. Must be one of the first little AVOs for the domestic market, become available in the 1930s. The Automatic Coil Winder and Electrical Equipment Company Limited in London, and of course that made up the word of AVO, which has been their brand name for many years. So that's the little AVO Minor. What a nice one. The next multimeter which we have to show you is the one by Ferranti, and this is rather unique because it has the different resistance units which you plug into the probe for different voltages. It has a multi-range switch on the front here for different voltage and milliamp selection, and also the resistance range as well. Connections are made on the top of this meter for the different ranges. For the high voltage, it's AC and DC, a moving coil meter, for the high voltage readings on this meter, you pulled out one of these little resistors like this and inserted it in the top of the meter. What you've done is actually place the resistor in the terminal at the top there, then the leads themselves plugged into the resistor like so, and you had your common over here which went down into there. And so you could extend the high voltage range. There are another 3 resistors there which you could actually plug in series. So you had quite a number of ranges on the high voltage side of this little multimeter. Quite a nice one, made by Ferranti. In the back of the box, underneath the meter, is the chart showing you all the different resistance ranges that you can put into this meter. These little cylinders, shaped resistors. 1942 this one was made. So we are, that's a little Ferranti multimeter. The next one we have is a rather large one here, which you can see, and this is the Taylor Model 90, which was, I would have thought, around about the sort of wartime era or just after. Moving coil meter, of course, and the usual multi-range switch here, adjust ohms, AC and DC, up to 1000 volts this one, and I think possibly about, it's 1000 ohms per volt AC and DC, so not terribly high. There's all the instructions on the back of this meter. It's in a metal case and quite a heavy duty meter. There we are, that's the little Taylor Model 90 Series 8 multimeter. Well, that's all I have to show you in the multimeters. I have a lot more of the smaller meters, of course, but I think that's enough of them. Quite interesting and all quite readily available if you keep your eyes open at these various events. These are some of the components which I've collected over the last few years. Some of them are very interesting, some are brand new in their boxes, some have been in a bit of sorry state which I've managed to clean up and make them look like new. And we'll go around, there's far too many to go around individually, but what we will do is just take a group of them and have a look at some of the more interesting ones. So let's just have a close-up view of some of the components which we've got. Here are some of the components which we've collected in their boxes. Grid leads, tuning capacitors, various types of tuning capacitors, a very early switch there dating back to the 1900s, variometer, and various tuning coils and chokes which you can see there, and the very popular switch there for the aerial, grounding the aerial down to earth. Very special coil winding for wave winding, which we'll show you how that worked in a moment. Some of the very early Belling terminals you see there. There's a good range of the various types of grid leads which were available. TCC capacitor, the paper type of course. In the front there some brand new box Jubilee grid leads, valve holders, and a crystal in this little tin there. Variable resistors there, and various types of switches. There we can see some of the tuning dials which were the thing of the day, of course, around about the 1920s, 25. And these ones are absolutely brand new, never been used. Here's a selection of the various types of grid leak that were available in the old days, and resistors. There's the Varley resistor, see mounted on a little piece of Paxil there. This one is a resistor and a capacitor all on one unit. Another resistor here, the Jubilee one. These are various grid leaks. The most common one amongst them, of course, would be the Graham Farish. That's that one there. And all of these are grid leaks. Some are glass encapsulated, like almost look like little festoon lamps. Some will have terminals, and the others, of course, are meant to clip in little frames, like this one here. Some rather large variable resistors here. What they do have in here is discs of carbon which are compressed by turning this control here, which of course lowered the resistance. These ones here are glass encapsulated, meant for soldering directly in. So there's a selection of the various types of resistor and grid leaks that were used in the very early radios. Here are a few of the valve holders which were used in the early days. This one, as you can see here, was for mounting directly onto the panel, onto the chassis rather, that way. And of course this is a very, very early one here for the V30 valve, the Marconi valve. Of course in the early days, the early radios, they suffered terribly from microphonic. Any vibration would cause a noise in the headphones or loudspeaker. So they got over that by mounting them on springs. This one's made by a company called Arctic. It's rather large, and it's got anti-vibration, anti-phonic. This one's by a company called Triumph, and it's rather an unusual way they make these springs. These are leaf springs here in each corner, grid, filament, and the anode. As you can see, they wobble about like that. So quite an interesting little valve holder, that one. This one's made by a company called White Line, and has terminals, of course, here, and the way they do the anti-vibration is on these springs here, which you can see moving about. This is another little one, as I said before, for mounting directly onto the chassis like that. Here's the valve holder for the Marconi V30 valve, for holding the valve there, and as you can see the base is in the same configuration as the standard 4-pin or 5-pin, and just went straight into a base there for mounting onto a panel. This is a very interesting switch which I found at the boot fair, the National Boot Fair by the Shuttleworth collection up at Biggleswade, and I paid 10 pence for this, and you'll see one of these switches mounted up on a wall at a mock station at Amberley Chalk Pits Museum. It dates back to about 1916, and it's a switch for the aerial and earth circuit, where you could, the aerial and earth would be on the centre here, that's right, aerial and earth, and it would go to the transmitter in that direction, or of course you could short it out down there in that direction. But a very, very nice switch, complete brass with copper contacts here, with its pattern number on the front there. But that was a good 10 pence worth from the National Boot Fair. Here are just 3 of the dials which I've collected. I've got a lot more, but these are absolutely new, and of course survived in a very, very good condition. It's a very, very nice slow motion dial here with the numbers, of course, across the top here, 0 to 100 on the bottom scale and 0 to 180 on the top scale. This, I should imagine, this bottom part was for logging in and writing on the dial the stations that you picked up, so that you could make an easy tune to them. So that's the little dial made by Ormond. On quite a number of the sets you would have seen this in the early 1925, 26 and 27, that's the sort of dial they used. We'll have a look at this one now, which is made by Indigraph. This is quite a nice fine tune on this one. There we are, that's the little Indigraph dial. This one here is the utility micro dial, which is got a nice slow motion dial. This type of dial, you could turn this part of the knob and get to a very coarse tuning, with the fine tuning was achieved by turning this inner control here. Well, here's a few of the switches which we've got. Some of them were just plain on-off switches, and others were wave change, and also the aerial switch, where we had the aerial connected to the centre here, and the set on here, and the earth there, so you could short the aerial, put the aerial down to earth. They were always very frightened of lightning, it appears, in the early days. There we are, we can see the box, absolutely brand new, this switch. Switch is made of porcelain, the base, as you can see it's written on there, on off, so you could ground the aerial. This one's by GEC. This one's interesting, you can see the little spark gaps it's got down here. In case lightning come along and you didn't notice it, it would probably flash over here down to earth. But this one's of white porcelain. It's a rather ingenious switch, changeover switch. As you see, these two bars from here, they short out from this part here up to here, of course then over to there, and it's a sort of double pole, double throw switch. We can see the connections here, solder connections onto the contacts for the switch, and this one's made by, it says here, the utility. It's British made. This is a nice little switch here. As you can see, the front says on or off by pushing the control in the front here, and the two terminals are at the back here, on the sides rather, and the connection is made across this at the back here. Quite ingenious the way it turns the little dial. We'll have a close-up look at that. The dial's turned by pushing this control in and out, and you can see the little twist on the shaft there, which rotates the dial inside. This one's the same type of switch, same make, but on the front of this one it reads radio, or if you pull it out it will read gram. Another one of the standard type of switches that we used in the old days. It's rather stiff, but a very nice little switch. This one's a little bit unusual, where you pull the control and it pulls this part in and makes contact with the three contacts on the back here. As you can see, you just pull it in, and there's the three terminals. This one looks a little bit more elaborate, quite a large switch this one, just that two-pole changeover again, but quite nicely made, and this one's made by a company called Lotus. Tuning capacitors, the one thing which haven't changed over the years. They've always been the same. Some of these are very, very early ones, but there's been absolutely no change in the design. Of course, but they've got a lot smaller in the modern equipment, except for the transmitters, of course, where you use the wide space ones like this here. This one's a truly magnificent one, made by Silden, which is a British manufacturer. This capacitor is completely all aluminium, the vanes and the fixed, the rotator and the fixed vanes are all aluminium, including the end plates as well. Absolutely in new condition. Dates back to about the 1930s. This one's made completely of brass, 2 gang, and extremely heavy. This tuning capacitor I stripped down completely and rebuilt it, polished every vane of the capacitor. It's a rather interesting one. It has a built-in slow motion drive. It took about 3 weeks to clean this one, on and off, sort of evenings, over an hour here and there, but completely refurbished this. And a very nice tuning capacitor. These two are same manufacturer. This one, of course, is a split stator capacitor, and this one, the ordinary standard. It's called Keystone Midget. That's the manufacturer of these two. This is another one. Brass vanes and nickel plated frame on this one. Very nice one. No slow motion. One that's got to be cleaned up and tidied up. So that's the end of the tuning capacitors. We'll move on to some other components. Here are a few of the cat's whisker holders that you could get. This one here, of course, was an unusual one. It had a piece of crystal in the top and the bottom there, a bit of gleaner, and then you made the adjustment on here. It was sort of spring loaded. This is an unusual detector. There's no cat's whisker. It's obviously 2 pieces of gleaner compressed inside there, and it's a detector. They call it the Carborundum Company Limited detector. Permanently fixed. Here's the neutron wireless crystal and cat's whisker supplied in a nice little metal tin. Here we are, there's the cat's whisker and the piece of galena, complete with its instructions. Here we have a few of the early capacitors used in radio. In fact, they're not really capacitors, they're called condensers in the early days. We'll have a close-up look at some of them. They're quite interesting. As you can see, some of them are complete with their original box. This is the Jubilia microcapacitor or condenser, as we'll have to learn to say, complete with this nice little box. This one's the same type of condenser as the other one, but this one has the two clips for the grid leak to be placed in. This one's the Jubilia condenser type 577, all in a little metal case, nickel plated, and it's a high voltage one, it's 1000 volts. A little TCC capacitor. I should imagine this one's a paper capacitor, two terminals on here where you can either solder on this part or use the screw terminal. Another Jubilia condenser. This one has two screw terminals on the top and two holes for fixing onto the board. There's another TCC model, but this one is in a sort of either Bakelite or some sort of moulding, where the other one of course was in a little metal can. This is the Formo condenser. It's variable condenser from 1000 pf to 2000, 0.001 or 0.302 in fact, so it's down to what is that, 20 pf up to 1000 pf, and you turn this little control at the top here, two terminals. This is the little box that the Formo denser, as they call it, came in, and as you can see, its price was 2 shillings. It says on the side here, for use as a neutralizing condenser, aerial condenser, grid condenser, reaction condenser, tone control condenser, etc., etc. The conditions of sale and limited license to sell this condenser are quite amazing. Let's see if we can read through them. It says here, the owners of the patents grant to the purchaser of each article and to any person into whose hands it may come a limited license to use or sell the same, on the express condition that it is not retailed or advertised at less than the retail price indicated in the Formo current catalogue, and that no allowance, bonus, rebate or other consideration be allowed, whereby the ultimate retail price is less than the current list price, and that it shall not be sold to the trade for resale at less than the current list price and discounts. Acceptance of goods implies acceptance of these conditions. Agents and distributors are not empowered to vary this license. I don't think they'd get away with that now. We have here just a few of the early variable resistors that we'll show you, of the most interesting type. This one's a very interesting pot. It's made by a company called Lewcos, that's Lewcos, and it's a 10,000 ohm pot. But look at the way it does the track. It doesn't have a wiper that goes around, it has this disc, and as you can see, the disc varies, goes round on the carbon track and makes the connection. So there's no actual wiper, and the disc is just actually laid onto the carbon track as it goes round. A very interesting pot, this one. Two connections here, that's each side of the carbon track, and the one on the top here is the connection for the wiper. This one's by a company called Igranic, and it has a window in the top here that when you turn the pot you can see the numbers change. So it's a sort of calibrated potentiometer, but a very unusual looking potentiometer. Looks as if it's not sure quite how this was. Oh, it was to be mounted through here. There's a number of things. So it went through the panel, that went onto the front panel, then you had the control, then the connections were on these three terminals here. This one's a wire wound pot made by Igranic, and it's rather unusual in that the actual winding moves round the wire wound part, as you can see. So we turn it like that, and there's the wiper contact. The other contact is up here on the rim. So this is the action of this particular potentiometer. Rather unusual, isn't it? This is another one by Igranic, quite a low resistance, as you can see by the thickness of the wire going round, and this one operates in the same fashion. This one's called the Bradley-ometer, and it has a ceramic part here with the nickel plated end caps, and turns like that. That's the control. Quite an unusual one. It's an American one, this one. Here are a selection of chokes used in the very early radios, and some of them are quite magnificent and very nice design. This one's the Telson HF choke. It looks very much like a little clock, all in a Bakelite case. One's another little HF choke. So this one, of course, you can see is round, ready to be mounted directly onto the board, made in Bakelite again. This one's by a company called Graham Farish, who made a lot of components for the very early radios. This one's by a company called MH, and it's called the Beehive choke, another HF choke, and it has 60,000 microhenries is the inductance of this choke. This is rather an unusual one, a twin choke, HF choke by Telson. This one's by Varley, and it's a multi-cellular choke. Quite a popular choke, HF choke again, and you can see the way this one was made. Very nice little choke, that one, and quite a popular one. This one, this HF choke, is by Listen, who made a lot of components in the early days. Quite a nice little choke. This one's in a metal can. It's made by Wearite, and quite a nice little choke again. This is the earthing tag for the metal can, and the connections are either side. This one is by Wearite. These are two quite interesting power resistors made by Varley, and as you can see, very nicely made, complete with a little holder that the thing clips into. So you could use the same holder, and you put various value resistors in. The connections at the top here, of course, and the bottom there. And the same with this one. This is just a different model, different resistance, but both of those are by Varley. This one's a very nice little slider resistor, variable resistor again, but very nicely made, with the connections, 3 connections, one each end of the resistor, and the sliding contact is made up on this one here, on this terminal here. This, I believe, is a resistor. I'm not too sure. It has these carbon discs in there, which are compressed by turning this control knob here, and it does say on the top here, listen stat, and on off. That's all it says. So I believe that is some form of a very early variable resistor. The other one I have here is a similar thing, but a smaller version of it with smaller discs inside. We have here a selection of the coils used in the early radios by various manufacturers, and we'll have a little closer look at them. This is probably one of the most the earliest coils I have, tuning coils, which is called the variometer, and it has a winding which goes around the outside here, and this one of course on the inside for tuning. Has a control knob on the top here, calibrated 0 to 10. This is probably one of the most popular type of tuning coils that were around in the early days, and it's tuned inductively like this on this control, which is rather a long shaft. But that's how the tuning was achieved with this type of capacitor, with this type of coil rather. Here's the wave wound coils and the frequency which they covered, of course written on the top. And of course these are the world famous ones which said, "What are the wild waves saying?" The frequency this coil covered was on a little graph on the side of the coil, 400 to 2000 meters. So there we are, that's the coils which say, "What are the wild waves saying?" Of course, for the home constructor, the Edison coils were available, and here are a few of them in their original boxes. Edison radio, Stratton and Company, Birmingham, England. This is the little Edison plug-in coil which most of the shortwave sets used, and it has a coloured dot here. This one is the yellow one, indicating the range which this coil covered. This one has a different tuning range, indicated by the two blue dots, which is about 10 meters, this range on this coil. This is another of the popular type of coils. This one's made by Airmex and has a piece of like celluloid around the outside, and the standard pin configuration, one pin and a socket. This one here is the same type of thing again, where we have the coil which plugs into the holder just for the single tuning. This one is the 50, number 50, it's called iGranic, and it tunes 150 to 700 meters. Another little coil by MH, tuning range 300 to 600 meters, and has the standard 4-pin valve base configuration for the contacts. This one's the Discol Tangent 400. I take it that's the wavelength is 220 to 3000 meters. Same pin configuration again. This one's an American coil made by a company called Marshall, and the contacts, as you see, around here, and plugs into the base like so and makes contact there. Inside the coil it has this another little coil which you can turn to alter the inductance of the coil. This one's an interesting coil. It's a split primary transformer. It tunes from 1000 to 2000 meters, and it says tune with a .305 condenser. It has LEW written on it, L-E-W, and says the London Electric Wire Company and Smiths Limited. As you can see, it has at the base 6-pin base there, I believe it, 6-pin base. This is a rejector made by Ferranti, and the connections are rejector in on that terminal there, rejector out at the back, and aerial to set on this connection here. It's tuned by the control knob on the top. On the base is the diagram of connections for the rejector, and this one says that it rejects a frequency of 356 meters. This is the item they used for winding these coils, the wave wound coil, which is quite an interesting thing, and this is what you needed to make it. What you actually done was to get the wire, and you'd wind it in and out of all these loops here until you built up the whole coil. This is what the coil looked like when it was finished, and of course you could make the taps come out on the here. These are the connections to the various parts of the tuned circuit where you needed to tap off the main coil. These pins are placed in the holes here so that you could build up the coil to the sort of weave that, or the wave that you wanted. But it was a very nice find, this, to be all complete with the little posts that you put in. So there we are. There's a reel of the original wire, which is the cotton covered wire which was used to make the coils. Here we have the Ferranti interstage transformer with the grid here, grid bias connection on this one, plate, and the HT on the terminals here. Very nice transformer, completely enclosed in a metal case, and this one's in extremely good condition. Now what we have next, this was one way of coupling the circuits, of course, with the transformer. The other way was with one of these units, which is the Mullard PM resistance capacity unit. This coupled the various circuits without the aid of the transformer. This is a very interesting little gadget. It's an American device sold to go in series with the filament of the valve, and it saved having the rheostat where you could adjust it manually. This done it automatically, so it claims. This comes complete with a little pamphlet telling you what valves to use it with and how to fit it into the radio. It says here, Amorite is the self-adjusting regulator for amplifying tubes. It really takes the place of rheostats, filament meters, and an expert operator. With soft detector tubes as the UV200, because of their variation in gas content, we advise the use of a rheostat in the detector circuit only. Perfect for every type of hookup, approved by every prominent laboratory. The set equipped with Amorite never grows old. Amorite means right amperes. Well, there's just some of the components which I've collected over the last few years, and they're quite interesting. I have a lot more, but just not enough tape, I'm afraid. We will be making a tape of some of the radios which I've collected and trying to demonstrate some of those. So I hope you've enjoyed this first 3-hour tape.